Today is going to be 32-2. We're going to be finding the angles using inverse ratios for tangent and the reciprocals. So we're going to utilize the unit circle to find the angles of common ratios. Now, as just a reminder, just remember that if you have a trig function equaling some ratio, if you were to take the inverse to both sides, that would cancel out with our trig ratio, and you're going to be left with an angle. So if you ever have the inverse of a ratio, it always represents the angle. And so we're going to use that analysis to find the angles on our unit circle. So for example, if I have the cotangent of theta equals the square root of 3, well, going through this, we know what tangent is, we know what sine is, we know what cosine is. So let's relate our cotangent with those to be able to help us. So if I were to turn this into 1 over tangent, well, that just means I need to find the reciprocal of this, which is 1 over root 3. So I need to ask myself the question, where is my sine over cosine going to be 1 over root 3? So I need to go through these. If I do sine over cosine, that's at the 30 degrees. That's going to cancel out, and I'm going to get 1 over root 3. So that works. And so I just need to find where the reference angle is, which is going to be all the way over here. And so that cancels out, and you also get 1 over root 3. So it seems like it's going to be pi 6 and 7 pi 6. Looking at another one for secant. Well, I want to relate that to cosine. So if I relate that to cosine, I'm going to flip this, so I get 3 over root 3. Well, if I rationalize that, that's going to give me 3 radical 3 over 3 as a negative. Those are going to cancel out, and so I'm going to get negative root 3. So I would have to take the cosine inverse to both sides, so the cosine inverse of negative root 3. Now if you were to enter that into your calculator, there's not going to be any solution. The cotangent of theta equals 1. Well, here, if I relate that to tangent, so I need to ask myself, where does my sine over cosine give me 1? So you start comparing them again. Well, we just tested the 30 degrees. That gave us 1 over root 3. Let's test the 45 degrees, or the pi fourths. So you get radical 2 over 2 over radical 2 over 2. Those cancel out, and you're left with 1. And so the next reference angle will be all the way down here at 5 pi fourths as well. So both of our answers are pi fourths and 5 pi fourths. Where my cosecant equals 2. So we want to relate this to sine. So if I do that, you do the reciprocal. So now where is my sine 1/2? Well, if I take the inverse to both sides, so theta equals sine inverse of 1/2. So we're asking what angle gives me that ratio of 1/2. So we look at the unit circle, we know that's going to be here and here. So that's going to be pi 6 and 5 pi 6. Where my cosecant theta equals 0, we know that cosecant relates to sine. So if I do the reciprocal here, well, if this is 0 over 1, then I need to flip it, so I get undefined. So it's asking, where is my sine going to be undefined? Well, sine isn't undefined in any value in my unit circle, so there's no solution. Which just means there's no angle that's going to give me an undefined value for sine. For secant, secant relates to cosine. That's the same as radical 2 over 2. So where is my cosine going to be radical 2 over 2? You know, if I wanted to solve this formally, you take the cosine inverse to both sides. So you get theta equals cosine inverse of radical 2 over 2. And so that's going to be here at pi fourths, and it's also going to be here at 7 pi fourths. In closing of today's lesson, what did we learn today? Well, we examined inverse trig ratios with tangent and its reciprocals, and we found the angles as it corresponds to the unit circle. Now, what did I relate my reciprocal functions to, and what do inverse trig functions represent? I want to hear from you guys. Now, this does conclude our lesson. If you have any other questions, please leave them in the comments.